Good evening, everyone. Good evening, friends. Welcome back to our sessions on regression. So, this particular playlist will have the complete information about the regression algorithms as part of machine learning, right? So, we'll quickly recap what we have covered in the previous sessions and then we'll start the topic for the day. So, machine learning, just give me a minute. Yep. So, let us recap, friends. Machine learning is classified into three types. What are the three types? What are the three types that we are aware of machine learning? The types. So it's broadly classified into three types. One is unsupervised learning, supervised learning, and reinforcement learning. Then supervised learning is again classified into two types: classification, regression. Classification and regression. On what basis we have the types under the supervised learning? Classification and regression algorithms are divided based on the values that we have in target column or output column. It is nothing but y. So this particular playlist will have val- this playlist will have the complete information about the regression algorithms. Again, when should we use regression algorithm, or what is the general meaning of regression task in machine learning? Regression algorithms are used when you have continuous values, when the values under the y column, under the target column, if they are continuous, then we use regression algorithms. What are the regression algorithms that you are aware of? In the last session, in the last 3 to 4 sessions, we have understood a very widely used regression algorithm called as linear regression, right? Yes. Linear regression is used when you want to predict a continuous output. Whenever I want to predict a continuous output, I'm supposed to use linear regression algorithm. So the relation between the inputs and the output, independent and the dependent variable, will be linear. Okay, the equation is similar to equation of a straight line, y is equals to mx plus c, and it works on OLS method, ordinary least squares, where the main objective of this method is to minimize the error, y minus y cap error. So this is something important and we have already covered it in our previous sessions. So friends, if you are joining for the first time, okay, if this is your first session as part of our YouTube channel, we have already covered the classification algorithms, and linear regression algorithm was also covered in our previous playlist. Okay, so in the previous sessions I have covered linear regression. So just go through the sessions and gain knowledge on linear regression. Okay, yes. And in today's session, we are going to learn one more type of regression algorithm. It is logistic regression. It is logistic regression. So linear regression is used to predict continuous data if the values in my target column are in my output column are continuous, then I generally use linear regression. Linear regression is generally used. But when is logistic regression is used? Logistic regression is used for classification task, isn't it? Yes. If the values in your y column, in your output column, if they are discrete, fixed, examples, pass, fail, okay, then 0, 1, okay, uh, cancer, no cancer. In this way, if you have a binary class, the values are discrete, and if they are binary, logistic regression is preferred. Akhil, then why it is falling under regression? Okay, we'll understand. Just not because of the name. It is a type of regression, but which is not used for predicting continuous output. Still, it is used for predicting a classification, a discrete value, a discrete output. Okay, so this is the overview. Let us understand how logistic regression works, what method, what technique is used to, used as a backbone uh, for the working principle of logistic regression, and what are the evaluation metrics that we have. We'll understand, as well as the types of logistic regression that we have. Everything we'll understand, friends, as part of today's session. Excuse me. Right. You see, we have the agenda. We'll just get introduced to the regression, logistic regression. Then we'll understand the types of logistic regression we have, and like how linear regression have some assumptions. We discussed line assumptions, linearity, independent normality, and equal variance. So, like how linear regression has line assumptions, even logistic regression have some assumptions. We have to discuss them. Then we'll compare both linear and logistic regression. Okay, we'll have an introduction about. We'll get introduced to sigmoid function. So this is what logistic regression use. Okay, this is very important function, sigmoid. We'll also discuss more about sigmoid function as part of the next module, neural networks. Okay, and the finally MLE, maximum likelihood estimation. So this is the uh, technique that was used by logistic regression to predict the discrete values and the evaluation metrics. So one by one, we'll understand, friends. Just focus. So again, I'm just giving the overview. Okay, once if we complete the theory part today, we'll have a hands-on session. We'll work on a project on using logistic regression. I'll implement the concepts of logistic regression and build a model. Okay, a logistic regression model will be built on the data in tomorrow's session, right? So focus and let us get started. What is this logistic regression? You know, the first point says it is a supervised learning algorithm. Yes, it is part of supervised learning, but used for classification tasks. Even though it is named under regression, it is not used to predict a continuous variable. Okay, it is used to predict again a discrete variable where we have binary class, two classes only. So despite its name, it is not a regression algorithm, but rather a probabilistic classification model. It's a classification model. Okay, logistic regression produces the output in binary format. Okay, especially if you see here the examples, yes or no, true or false, 0, 1, high, low, the value should be discrete, and moreover, there should be only two classes. In such cases, we use logistic regression. Okay, in order to classify the two classes, the binary classes, we can use logistic regression. You can have n number of inputs. When you pass all the inputs, it is used to classify the two classes, either happy or sad. Okay, right. So this is just a basic introduction to logistic regression. Now let us talk about the types. Types of logistic regression. Logistic regression is again classified into three types. Okay, so the default one is binary logistic regression. Okay, which is used to uh, predict where the dependent variable has only two categories, two classes. Yes or no, true or false, success, failure, default, non-default. Okay, so in this way, if the output variable under the y column, if there are only two classes, we can use binary logistic regression. That is nothing but the default logistic regression. What? No, Akhil, I have more than two. There are more than two classes under the y variable, under the target column. So can't I use logistic regression? We can use logistic regression, but it is a type of logistic regression. It is called multinomial logistic regression. It is named as multinomial logistic regression. What is the purpose of, or what does this multinomial logistic regression does? If your dependent variable has three or more than three categories, that means more than two categories. If your dependent variable has more than two categories, then we can use multinomial logistic regression and make sure that these three or more than three categories are not ordered. What do you mean by ordering, Akhil? So friends, in the previous playlist, if you remember, we discussed the scales of measurement, right? We discussed the scales of measurement in which we have nominal, ordinal, interval, ratio. I hope you remember. So friends, if, in case if you did not go through our previous sessions, do watch 30 days free short-term training from Python to AI. Okay, as part of this playlist, all the fundamentals have been discussed. So I have explained all the fundamentals. So just go through that particular playlist because the fundamentals are very important, right? Yes. So what does nominal data means? Nominal data means it's just an uh, identity given to a place, a person, okay, or anything. Then we also discussed ordinal. Ordinal means the data which can be ranked, ordered, is called ordinal data. In the same way, if the classes that you have, if the categories that you have under the y column, if they if these categories are not ordered, we cannot order them, okay, in a meaningful way, then we can go and use multinomial logistic regression. Why should we use only multinomial logistic regression if the values or the categories are not ordered? They cannot be ordered because if they can be ordered in a natural way, okay, if they can be ranked, and if your y column has more than two categories, three or more than three, okay, then you know you can use ordinal logistic regression. Ordinal logistic regression can be used, friends. So I'll just compare all the three types of logistic regression. One, binary, multinomial, and ordinal. Binary, multinomial, ordinal. If the classes under the y column, if there are two, if we have exactly two classes, then we go and use binary logistic regression. If we have more than 3 or equals to 3 categories under the y column, and these cannot be ordered, if there is no order with respect to these categories, we go and use multinomial logistic regression. Ordinal, if they are more than 3 or equals to 3 categories, and if they can be ordered or ranked, we use ordinal logistic regression. Okay, so as part of this particular session, we are going to discuss binary or logistic regression. These are the types of logistic regression, and we also have you know other types of logistic regression, but this time based on number of independent variables. That means based on inputs. If you want to categorize logistic regression based on inputs, it is of two types: simple, multiple. Okay, just give me 1 minute. So you mean, is it similar to linear regression with respect to the types? Yes. Do you remember linear regression types? Yeah. Based on number of independent variables, linear regression is also classified into two types: simple, multiple. So how do you define simple linear regression? If I have only one input variable, excuse me, sorry, if I have only one single input variable, then it comes under, we are supposed to use simple linear regression. If I have multiple variables, more than one, two or more than two, then I'm supposed to use multiple linear regression. In the same way, logistic regression is also classified in a similar manner. If you have only one input variable, it is simple logistic regression. Okay, you see here, example, predicting, you're going to predict whether a student will pass or fail in an exam based on just one variable, study hours. What is a variable? Study hours. What is multiple logistic regression then? Same, two or more than two. Two or more than two. The example, I try to predict a customer will buy a product or not, yes or no. So obviously, under Y column, you will have only two classes because we are talking about binary logistic regression only. The default logistic regression, binary, we are talking about binary logistic regression only. Okay, so what am I doing here? The number of inputs is being changed. Under simple logistic regression, it's only single input. Under multiple logistic regression, the number of inputs will be two or more than two. I hope it's making sense. Okay, so far I assume no questions because this is something that we are well aware of. Now let us talk about the assumptions. Let us talk about the assumptions that logistic regression follows. Logistic regression assumes that the observations to be independent. Each observation should be independent of the other. Okay, so that means there should not be any correlation between the input variables. The input variables that we are going to have, there should be no correlation between them. The correlation among these variables should be very weak. And binary dependent variables. Okay, so whatever the y column that you're going to take, the output column, under this, you'll have the classes, right, as part of the dependent variable. So this dependent variable which holds the binary classes, okay, it should take only two, and moreover they should be independent of each other. They should not depend on each other. Okay, then the relation between the independent variables and the log odds should be linear, and the sample size should be large. The data that you're going to work should not be that much small. Okay, so at least in order to train the model logistic regression, you should have sufficiently large data set only, and it is assuming that no outliers are present in the data. But even though if you have any outliers, the model performance gets down. That's it. Right. So these are the basic assumptions. We have to consider these. Now let us discuss what exactly is logistic regression, how it works. But before understanding logistic regression, we'll quickly recap linear regression, friends, because this logistic regression is going to use the same equation of linear regression, okay, and that particular linear straight line equation is getting changed as part of logistic regression. So this is the equation that we have: y is equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta n xn. So what does beta naught represent? It represents y-intercept. Beta 1, beta 2, beta 3, beta and so on, they represent coefficients. They all of them together represents coefficients. x1, x2, x3, so on, xn represents the inputs and y represents the output. Right? Yes. So if I use the same line, okay, to predict my output, obviously I can get any value. Yes. I can get any continuous value. But what is the purpose of logistic regression? This is used to classify. Then how come this equation is going to help us? Is we'll understand. If you see here, linear regression produces values from minus infinity to plus infinity. Yes. Between this range, we can have the output for a linear regression use case. But for classification, okay, the output should be, 0 and 1. In short, logistic regression is going to, predict probability. If you observe whatever algorithms that we are discussing, as part of classification or regression, probability concept is being used more. So if you want to excel in the field of machine learning, artificial intelligence, this is a must and should topic that one should be aware of. Okay, I request all of you to go through the concepts of probability, understand the concepts of probability. Okay, right. So logistic regression is going to predict the probability of a class. So when it is predicting the probability of a class, the output will be between only 0 to 1. Yes, it will be between 0 to 1. Okay, for example, I'm using logistic regression to classify. Okay, I'm using on a data set for a classification task, and for one particular instance, for one particular observation, it has predicted the probability as 0.3. So to which class does it belongs to? Does it belongs to pass or does it belongs to fail? 0.3. So this is what we are going to understand. because I can get any number between 0 to 1. Am I right? Yes. I can get zero point 0.9, I can get zero point 0.1, I can get 0.15, anything. But how this probability is converted to a class is what we are going to understand. So, instead of using a linear function, logistic regression uses a function, nonlinear function called sigmoid function, and it is also called as logistic function. This is very important function as part of neural networks. The next topic that we are going to discuss in the coming module, I'll talk about more about this sigmoid function. This sigmoid function is a nonlinear function, and this function converts any real number to a value between 0 and 1. So whatever the number that you get, okay, so when you try to predict what exactly logistic regression is predicting, it's predicting the probability. So probability can be any number between 0 to 1. This probability, the number that you get as output, will be converted to any a value between 0 and 1. How? How? We'll discuss. So this sigmoid function will have an S-shaped curve. Okay. So by default, it takes a threshold of 0.5. By default, it takes a threshold of 0.5. If the probability, if the value is less than 0.5, it goes and assigns 0 class, and if it is greater than 0.5, it takes or it gives class 1. If it is equals to or less than 0.5, it gives class 1, and if it is greater than, the probability is greater than 0.5, it predicts class 2. So this is how a nonlinear function, sigmoid function, is used to get binary class as output. Either 0 or 1 will be returned. But logistic regression is actually predicting probability. This probability will be converted to either class 1 or class 2 based by sigmoid function. By this sigmoid function, we'll get either class 1 or class 2 as output. That's it. So let us understand the graph. I'm comparing linear and logistic regression in one frame. Okay, so now I hope it makes more sense. So if you observe linear regression, on x-axis I'm taking independent variables x values, on y-axis I'm taking dependent variables. Okay, so what does linear regression does? The purpose of linear regression is to predict continuous data, and it is going to form a straight line. Okay, it forms a straight line, and the predictions can be between minus infinity to plus infinity, anywhere. That is what we have learned in linear regression. But logistic regression, no. The output will be between 0 and 1 because of a nonlinear function called sigmoid function. Okay, this is called as sigmoid function, and it is also named as logistic function, which is an S-shaped curve. And if you see the limits of this S curve, the minimum value is 0 and the maximum value is 1. Maximum value is 1. So if you take a threshold of 0.5 over here, if you take a threshold of 0.5, if the values of the probabilities, if they are greater than 0.5, it predicts as the first class, and if the values that are less than 0.5, it predicts class 2. So this is how logistic regression is going to work. It uses the sigmoid function. The calculation of sigmoid function will be used. right? Yes. So we also have a derivation, okay, how this sigmoid function is getting is converting the values of the probabilities to 0 and 1. Okay, we just need the output 0 and 1. So the probability will be calculated. Okay, so we have the concept of odds, and odds is given by this formula. Okay, so odds is equals to p by 1 minus p. P is nothing but the probability of event happening, and 1 minus p is nothing but the probability of event not happening. So this will be calculated, and we are taking the log of odds. So the log of odds is nothing but logic function, and finally we have the equation of the sigmoid function over here. I'll keep the formula. Sigmoid function is given by the formula 1 by 1 plus e to the power minus x. 1 by 1 plus e to the power minus x. Okay, so the value of the probability will be calculated and it will be substituted. Right. So if this value, when you are trying to solve the probability, okay, so if the value is very large, okay, so this becomes very small. So obviously p will be equals to 1, and if this value is small, e raised to the power that value is very large and p will be 0. Probability will be close to 0. So this particular function ensures that our model always gives probability as outputs based on the threshold. you know the threshold by default it is 0.5 friends. You can change this threshold. Okay. Yes. So and finally we have the formula here. So this is just an derivation to find how logistic regression equation is obtained. Okay, the sigmoid equation that we are talking about, how it is obtained, we have the derivation. Just that's it. Now let us talk about MLE. In linear regression, which technique is actually helping to find the best fit line? Which technique did we use to find the best fit line? Come on, friends. Which technique did we use? Yeah, in linear regression, which technique did we use to find the best fit line? We are getting this best fit line, right? Across your scatter. Okay. So you get one best fit line. It is OLS. Good. Ordinary least squares. Ordinary least squares is a technique that is used by linear regression to get this best fit line. But logistic regression uses MLE technique, maximum likelihood estimation. Okay, so as part of the formula, the equation, we have the coefficients, right? Beta naught, beta 1, and so on. So these coefficients are calculated, they are estimated using MLE technique. So it is helping us to find the parameters that maximize the likelihood of observing the given data. So in classifying the data, it is giving the maximum probability. Okay, so MLE maximizes the probability that the observed outputs were generated by the model. right? So this is an equation for the MLE. You need not memorize this equation. This is not that much required. Yes, not required. Now let us talk about the evaluation metrics. These are very important. Okay, because even if you observe classification algorithms, they use the similar, they use the same evaluation metrics when we are going to finalize the model. Okay, so focus. The first one is classification report. So it is a report in which you will have the entire detailed information, precision, recall, F1 score, and support. We also have accuracy. What is 0 and 1? 0 is class 1, 1 is class 2. Two classes, right? So two classes. But what is precision? What is recall? What is F1 score? What is accuracy? Is the question, right? So let us talk about these, you know, let us understand these metrics first, then we'll come back to classification report. Right. So the first one is evaluation metrics. Under the evaluation metrics, we have confusion metrics. This confusion matrix is really a very important metric for a classification algorithm. If you are working on a classification task, for sure you have to go and cross check the values that you get under confusion matrix. So what exactly is a confusion matrix? So the name itself, we have an indication that it is a matrix. Okay, it is a matrix. I hope you are aware of matrix. Matrix is a combination of rows and columns. Rows, columns. In the same way, it is a matrix which is going to make us confused. Isn't it? Yes. It takes a lot of time for majority of the people to understand a confusion matrix. Why? What does confusion matrix actually have? It has four different values and they are TP, TN, FP, FN. What is this TP, TN, FP, FN? TP stands for true positives, TN stands for true negatives, FP stands for false positives, and FN stands for false negatives. No, did not understand that way. No worries. I'm there here to help you, right? Yes. Now let us focus on our confusion matrix. So confusion matrix is always a square matrix that you get. So friends, tell me what is a square matrix? What do you mean by square matrix? Come on. What do you mean by a square matrix? Good. Square matrix is nothing but, my friend says, n by n. What does that mean? It means number of rows will be equals to number of columns. A square matrix is a matrix in which you have number of rows equals to number of columns. So a confusion matrix is a square matrix. Okay, that means in a confusion matrix, number of rows and number of columns will be same. That's what I'm trying to say. Got it. Then how many number of rows will have? How many number of columns will have? At least if I know one, probably I can understand, right? Will I have every time only two rows, two columns? No. No. This number of rows will be decided by, or the number of columns will be decided by your class under Y column, target column. Okay, I understood, Akhil. If I have two classes. What is a class? Friends, we should be aware of all these terminologies. So, if you represent two class, that means you have two categories under your Y column. Example, true, false, or pass, fail. Yes, no. All of these fall under two class problem. This is a two class problem where you will have exactly two categories under your Y column. So in these cases, you'll get a confusion matrix with two rows and two columns. Okay, I understood, Akhil. But what if I have five classes under my Y column? I have five classes. Then what will be the size of my confusion matrix? Simple, 5 by 5. What will be the size of confusion matrix? 5 by 5. Making sense? If it is a two class problem, you'll get a confusion matrix with two rows and two columns. But if you have five classes under your Y column, obviously you'll get a 5 by 5 confusion matrix where you have five columns and five rows. Clear? Yes. But anyhow, since I'm learning or since we are discussing about logistic regression, this is not possible. I mean, binary logistic regression, this is not possible. So obviously, only this is possible. You can have only two values. But since this confusion matrix is an important evaluation metric for classification algorithms, if you take algorithms like Naibase, KNN, decision tree, okay, so those algorithms are designed for classification and regression both, right? So if you have five classes, yes, even this is also possible. Right. Now let us talk about the terminology. What is TN? TN is true negatives, TP is true positives. Actually, are you joking? No, friend. I'm not joking. Excuse me. Sorry. Let's get continued. Okay. So TNTP. Anyhow, I have the abbreviation here. True positives, true negatives. But what does they mean? What do they mean? Okay. I'll take an example. Then I'll discuss about these terminologies. Okay. Let us consider an example related to a use case where we have patients' data who are suffering from a disease. So there are two classes, disease present and disease absent, nothing but no disease. So these are the two classes that you have under Y column. Okay, so it's better if I disease present, disease absent. Two classes. Okay, so yes, disease present, disease absent. Out of these two classes, what is your positive class? So my positive class is disease absent. So I'll take this as positive class. Disease present, I'll take it as a negative class. Okay, so you are supposed to identify what is your positive class and what is your negative class. Once after identifying positive class and negative class, how many positive values, predicted as positive will become our true positive. Okay, so you have the historical data, right? In your historical data, you'll have some patients, okay, for which they have the disease, and for some patients they don't have the disease. So what is a positive class say? Our positive class says disease absent. So out of these folks, okay, For how many people our model is predicting. See, within rows I'm taking the actual value, and within the columns I'm taking the predicted value. I'm taking the predicted value. I'm taking both the classes, positive, negative. Yes. How many actual people, how many of the actual patients with no disease are predicted as is will become our true positive. Then, if you come to true negative, how many of our actual people, okay, with disease present, they have disease, okay, our model also predicting them as disease present, okay, so this becomes our true negative. Okay, my patient have disease and my model is also predicting that yes, this patient has disease. Good. Now let us talk about FPFN. What is this FPFN? FP talks about false positives and FPFN talks about false negatives. So that means these two cases are where the model predicts wrong. Here the model predicts the right, true cases. And in the false cases, the model goes wrong. So let us understand what is FN and FP. FN, my patient does not have disease. Okay, so positive rate, yes, the disease is absent, and my model says yes, this person has disease. Okay, so if you see, if you take FP, my patient does not have a disease. Okay, my patient has disease, but my model says no disease. Okay, so in these cases, the model goes wrong. So that's how we are supposed to interpret the values of confusion matrix. The values of confusion matrix has to be interpreted. Once after interpreting this confusion matrix, you can calculate the accuracy. Accuracy is very simple, the formula. The formula says overall true cases by the overall all four. TP by TN. TP plus TN by all the four cases will give you accuracy. Then what about error? Error is nothing but it is talking about in how many cases the model went wrong. So it is nothing but FP plus FN divided by all the four. TP plus TN plus FP plus FN. So we discussed, right, accuracy plus error equals to 1. If accuracy is TP plus TN by TP plus TN plus FP plus FN, you can calculate error. Just take this error, accuracy this side, you can calculate error. Right? Yes. So this is how you interpret the values of a confusion matrix. Once if you have all these values, you can calculate the rest of the values, the rest of the matrix. Precision, recall, F1 score, and specificity. Okay, so this recall and specificity will be used in our ROC curve. That is the next metric that we have to discuss. But I'll start from precision. Precision is nothing but it is talking about out of all predictive positives, whatever we have the positive class, out of all, how many were actually correct? TP by TP plus FP will return as the precision. Okay, then recall. Recall talks about the TPR, true positive rate. It is also called as TPR, sensitivity. Okay, so these metrics, whatever we are discussing now, are very important. Just, it's better if you by heart them, yes, because whenever you're going to do a project on classification task, you're supposed to bring out or carry out all these things. Okay, so out of all, again, the positives, okay, actual positives, how many of them are correctly predicted? So TP by TP plus FN, the false negatives, will calculate as recall. And once if you have precision and recall, you can calculate F1 score. F1 score is a harmonic mean between precision and recall. So we know harmonic mean formula, right? 2 into A into B by A plus B. A is nothing but your recall, B is your precision. So the same formula. And the range of F1 score is between 0 and 1. Okay, if the value of your F1 score is close to 1, that means the model that we have built is a good model. And if the value of F1 score, if it is close to 0, the model that we have come up is a bad model. And finally, specificity. This particular specificity is going to calculate TNR, true negative rate. Okay, so out of again actual negatives, Tn plus Fn, how many of them are actually predicted? We are going to calculate Tn by Tn plus Fn. Right. So memorize the formulas. Formulas are important. And the final metric that I have discussed earlier, okay, which is very important and which is introduced in our World War II. Okay, so this is actually part of World War II. We have ROC curve, receiver operating characteristic curve. This is a graph between FPR and TPR. TPR represents true positive rate, FPR represents false positive rate. Okay, so you're going to get the graph between TPR and FPR, and the model which is going to have, which is close to this curve will be a perfect model. That means FPR value should be 0 and TPR value, if it is 1, we say that the model that we have obtained is a good model. And you see the dotted line, if it is randomly classifying, you'll have both TPR and FPR as same. The values of TPR and FPR will be same. Okay, and if the graph of this ROC curve, if you see below to this random classifier, obviously you'll have a very worse model that was built, and you're supposed to get the model very close to this perfect classifier. Okay, now let us also talk about AUC curve. Okay, so the area under the curve will talk about your model, friends. If the area under the curve, if it is 1, we say that it's a perfect classifier. It is the right model that was built to classify our categories. And if it lies between 0.9 to 1, we say it as excellent model. If it is lies in between 0.8 to 0.9, we say it as good model. If it is between zero point 0.7 to 0.8, it's a fair model, and so on. If it is less than 0.7, I generally don't consider it, but anyhow, it is the worst model. Okay, if you have exactly 0.5, that means the model is randomly guessing. Okay, so this class should be part of, this record should be part of this class. This record should be part of the other class. So it is randomly guessing, but there is no kind of, right model. It's not doing in a right way. So it is randomly guessing. These models should be retrained to get the best scores. The area of the curve, area under the curve is something important to cross check. Right. So these are some of the important evaluation metrics that we go across when we are going and working on classification tasks. So use them as part of your projects, whatever you are trying to do as part of your classification task. Do calculate confusion metrics, the classification report, then precision, recall, okay, F1 score are mandatory. It's better if you also go and calculate the area under the curve. Yes, that is actually talking about your model, the model that you have built. So this is about logistic regression. We'll talk more about this logistic regression within project in the next session. So it's time for our questions. If you have any questions, yes, feel free to ask your questions. Friends, before you leave, I want everyone to share across your friends, ask them to learn these important topics, because if you are part of yes, we have also shared the feedback link. So give your valuable feedback, and we'll try to enhance our sessions. And yes, do share across your connections, and before you leave, hit on the like button. Okay, if you have any questions, yes, you can also post them as in our comment section. We'll reply within few minutes. Yes. So I assume no questions. It's a great day. It's a great session that was happened so far. We'll meet in the next session. Until then, take care. Have a great day. Signing off. Bye.